following is the tips for the problem-solving strategy when you are dealing with the rates of reaction. Firstly, I want you to read the question with the aim to understand it. As you read the question, understand, am I calculating the average rate? Am I calculating the number of moles of the limiting reagent? Am I calculating the number of moles that will remain behind after the reaction that has taken place? So it's very important to read the question with the aim to understand it. And then secondly, you need to identify which factor is being investigated. Are we looking at increasing temperature? Are we looking at increasing concentration? Are we adding a catalyst here? Are we looking at the nature of the reactant? So it's very much important to know what exactly in the question are we investigating. And then thirdly, refer to the collusion theory to always explain your answer in terms of the factor. Use the collusion theory to explain why increasing temperature will affect the rate of reaction, why decreasing concentration will affect the rate of reaction, or why adding a catalyst will affect the rate of reaction. And then the fourth one, average rate calculation. If you are required to calculate the rate of the reaction or to calculate the average rate of the reaction of either the reactants or product, you must know that there's not actually a mark for the formula for rate of reaction, because it can change depending on what you are investigating. It can be that you are given concentration. If you are given concentration, that means when you are calculating the rate, you'll use the formula rate is equals to the change in concentration of the reactants or product per unit time. And if you know the formula, you also know the definition of rate, because rate, it is the change in the concentration of the reactants or product per unit time. But the examiner can give you in number of moles, and they can say either use the following graph or use the information on the table or graph. And on that table or graph, you find that they've given you the number of moles. They say to you, then now you need to use that to define the rate of reaction. What is it that you do? You can't give us that the rate of the reaction is the change in concentration. No, you need to refer to the information. So therefore, you will say that the rate is the change in the number of moles per unit time, the change in the number of moles of the reactants or product per unit time. So that will be depending on what you are given. Now, these are not the only two that the examiner can give you. They can also say in grams, calculate the rate in grams per second. Okay, in grams per second. And remember, because we are dealing with chemistry, mass is measured in grams. If you are given kilograms, please do not forget to convert to grams. Okay, so you can be given in terms of the mass, you can be given in terms of the concentration, you can also be given in terms of the number of moles. Another thing I want to emphasize is that, remember, if you are calculating the rate of the reactant, you must always put a negative in front of the equation. Why do you put a negative in front of the equation? Because we know that the concentration of the reactants is always used up. It's always decreasing as new products will be formed. So that's why we put a negative, so that when we calculate, we always get rate as a positive answer. Very much important. But if you are calculating the rate of the product, then there's no need for you to put a negative sign, because we know that the concentration of the product is always increasing as new products are being formed. Okay, very much important to remember also the SI units. So here they can say calculate the rate in moles per second. So the SI unit here will be moles per second. Okay, and then if they say in terms of concentration, that will be mole per decimeter cubed per second. And then if it's in grams there, it will be grams per second. So it's very important to also take note of the SI units. And then lastly, number 5, it says stoichiometric calculations. Obviously, because we are dealing with rates of reaction, it's very important to remember your stoichiometric calculations. You see, this one is extremely important because you need to practice the basic stoichiometric calculations when you are dealing with rates of reactions, when you are dealing with chemical equilibrium, when you are dealing with acids and bases. So it's very important that you go back and look at what is it that I must know. So the tip that I always give learners, I always say to them, if you are given the mass in the question, just convert that to number of moles. Okay, even if you don't know what you are doing, just convert to number of moles. If you are given the concentration, also just convert to number of moles. If you are given the volume, also just convert to number of moles. And why number of moles? Because you will see that all the formulas under stoichiometry, they have number of moles. So it's very easy to just move from one variable to the other when you have the number of moles. And then lastly, number 6, graphs. I've already showed you the different graphs for temperature. Remember, the two graphs must cross, and as they cross, they form a T. T for temperature. Then the concentration versus time graph. Remember, the graphs, two graphs, but they don't cross or touch each other. The one that has the highest peak is the one that shows a higher concentration. And then the adding of the catalyst, I showed you two graphs. They can either use the Maxwell distribution curve. That's when you know the one with the lower activation energy is the one that is the catalyzed route, and the one with a higher activation energy does not represent a catalyzed route. Very much important. If you are given an exo or endothermic graph, you look for those dotted lines. Normally it will, or the one that shows a lower activation energy. So the lower the activation energy, that indicates that that route is what is catalyzed. Guys, let us quickly look at an activity together from a previous question paper, just a glimpse on how this question could most likely to be asked, just using different previous question papers. It says over here, 3 experiments A, B, C are carried out to investigate some of the factors that affect the rate of decomposition of hydrogen peroxide. Okay, this one we know if we write it correctly, it's H2O2. Very good. Then the balanced equation for this reaction is that as you are given. Then they say identical samples of hydrogen peroxide are used in each experiment. That means that the hydrogen peroxide is your control variable, because they made sure that they use the identical samples, or we can say the samples of hydrogen peroxide are your control variable. Remember, the control variable is the one that remains the same throughout the experiment. The condition used in each experiment are summarized in the table below. There you have experiment A, B, and C. You have temperature. Do we know temperature as a factor that affects the rate of reaction? Yes, we know that as we increase the temperature, the rate of reaction will be faster. So if you check here, A and B, they have the same temperature, but C has a higher temperature. So if C has a higher temperature, if I'm only looking at temperature as a variable or as a factor, I would know that experiment C will be the one that will have a higher or a faster reaction rate. Then over here, we were given some information without a catalyst, with a catalyst, without a catalyst. Now remember, catalyst is also a factor that affects the rate of reaction. So in this information, we are given 2 factors that affect the rate of reaction. However, we don't worry. We go to the question, we see what is it that the examiner requires from us. It says to us 5.1, in which experiment, A or B, is the reaction rate higher? Use the theory to explain, the collusion theory to explain your answer. Now remember what I said. I said it's very important to first know which factor you are investigating. Secondly, use the collusion theory to explain how that particular factor affects the rate of reaction. Now let's quickly see. We are looking at A and B. So if we are looking at A and B, what do we see here? Their temperatures are the same. If their temperatures are the same, what is different? The other one is without a catalyst, which is A, and then B says with a catalyst. Now we already know that with a catalyst means that we have added a catalyst in the reaction. And what do we know a catalyst does? It is a factor that affects the rate of reaction. And as we add a catalyst, the rate of reaction will be faster by lowering the activation energy. All right. Now they are saying to us, use the collusion theory to explain your answer. So already, which one will be faster? I know that B will be faster. How do I then get to explain using the collision theory. So over here, I've already wrote it for you. I said when you add a catalyst, or when a catalyst is added, the activation energy is lowered. We already know that because a catalyst is the substance that lowers the activation energy, and by lowering it, it makes the reaction faster. Now, more particles have kinetic energy equals to or higher than the activation energy. Now, because we have added a catalyst, that means that we are going to have more particles that will have the kinetic energy that is equals to or higher than the activation energy, or more particles will have sufficient kinetic energy, and then most importantly, more effective collisions per unit time, right? So the 3 marks, or rather the 4 marks, comes from there. This is normally a 4 marks question. Why was the first mark? The first mark is identifying that B is the one that will be faster. Then 3 marks is from saying, what does adding a catalyst do in the reaction? Adding the catalyst lowers the activation energy by creating an alternative route for a reaction to take place. Then more particles have enough energy or enough kinetic energy that is equals to or higher than the activation energy. Or you can say more particles have sufficient kinetic energy. Then lastly, more effective collision per unit time is very much important. Now, I also made a note for you. I said to you, it is very important to note that catalyst does not increase the kinetic energy. It does not increase the kinetic energy of the molecules. The catalyst, the only thing that it does, it lowers the activation energy. Remember, the catalyst does not form part of being a reactant or a product. So the job of the catalyst there is just to lower the activation energy, just to make the reaction to do what? To be faster. And more particles will then have the sufficient energy to match, sufficient kinetic energy. All right. Not that the kinetic energy is going to increase. All right. Very much important to remember that. Guys, let's quickly take an air break. We've been saying a lot. I hope this rate of reaction that we have done together, from the graphs to what is it that you must expect from, different previous question papers as you practice, to now, taking a break. And then when we come back, we are going to look at chemical equilibrium. Welcome back, learners. Now let's quickly look at question 6. What could be possibly question 6 under chemical equilibrium, okay? And what is it that you must expect in this question? Firstly, you need to know how to define open and closed system. Remember, an open system is a continuous system where there is continuous interaction with the environment, while the closed system is the system that is isolated from the external environment. And another thing that I want us to look at or to revise is the reversible reaction. Remember, a reversible reaction is the reaction whereby the product can be converted to reactants, and the reactants can be converted back to product rather, and we represent that using reversible reaction. Remember, reversible reactions, okay? That is what we use to represent a reversible reaction. And then the other one is chemical equilibrium. Remember, it's a dynamic equilibrium at which the rate of the forward reaction is equal to the rate of the reverse reaction. Very much important to know those definitions. The other thing that I want you to remember is to be able to list the factors that influence the position of chemical equilibrium or the equilibrium. Now, it's very important to remember there are only 3 factors that affect chemical equilibrium. And please let us not confuse chemical equilibrium with rates of reactions. Remember, under rates of reactions, there are 5 factors that affect the rate of reaction. But under chemical equilibrium, there are only 3 factors that affect the rate of reaction, which is pressure. Remember, when we talk about pressure, we only talk about the pressure of the gases. Then we also look at concentration. We also look at at temperature. Now, how do these factors affect the rate of reaction? If you increase or decrease the pressure, the chemical equilibrium will be disturbed. If you increase or decrease the concentration, the chemical equilibrium will also be disturbed. Or if you increase or decrease temperature. Now, very important, the theory that we are working with, or the principle rather, that we are working with under chemical equilibrium is Le Chatelier's principle. Remember, under the rate of reaction, we were talking about the collision theory. But under chemical equilibrium, remember you need to remember Le Chatelier's principle, and you also need to know how to state it. Remember, it says that when the equilibrium in the closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will always oppose the disturbance. So that is only the job of Le Chatelier. If you increase the temperature, Le Chatelier's principle will oppose that disturbance and try to decrease the temperature. And if you increase the pressure, Le Chatelier's principle will also oppose the disturbance and try to decrease the pressure. Now, it's very important to also be able to know how to apply Le Chatelier's principles to explain how increasing temperature, increasing pressure, increasing concentration affect what? Chemical equilibrium. Very much important. The next one is to be able to list factors that influence the value of equilibrium constant, which is our Kc. Remember, there's only one factor that affects Kc, which is what? Which is temperature or temperature. Now remember, how does temperature affect the value of Kc? The higher the temperature, the higher the Kc value. The lower the temperature, the lower the Kc's value. And how do we tell if the Kc the Kc value is higher or lower? If the Kc value is less than 1, then we know that means the temperature has what? Has decreased. The temperature has decreased. If the Kc value is greater than 1, that means that you have a higher Kc, which means that the temperature has done what? Has increased. So that is the only factor that affects the Kc value. And remember, what will give you a lower Kc value is if you have what? More reactants than the product. Reactants than product. And then when you have a higher Kc value, that means now your business is doing very well. You have now more of the product than the reactants. And that is what we try to achieve at all times, that you must have more products than the reactants, right? Now, what is it that you must remember? You must remember how to write the correct Kc expression. Now, remember the Kc expression, it is written as the concentration of the product over the concentration of the reactants. Remember, do not write, this is not the formula. This is just an expression that guides you how to write the correct expression. For example, if you are given a formula where we have H2 reacting with O2, which gives you H2O over there, and all these are gases, and then if we try to balance the equation, we have something like that. And then they say to you, write the Kc expression. Please don't start by writing Kc is the concentration of the product over the concentration of the reactants. This is just an expression that guides you to do it. So you need to actually apply what the expression is saying. So that means here you are going to have Kc is equals to the concentration of H2O, because that is the product. So the concentration of H2O, remember the coefficient becomes the exponents looking at the rows of Kc, over the concentration of the reactants. What are my reactants? Hydrogen and oxygen. Therefore, that will be the concentration of H2. The coefficient becomes the exponent, multiplied if you have two or more reactants or products. Their concentration must multiply each other, multiply with the concentration of oxygen, and that is 1, which is the same as to the power 1. That is how we write the correct Kc expression. And remember, the Kc expression, we only include the expression for only gases and aqueous solutions, okay? Only gases and aqueous solutions are part of the Kc expression. We do not, please NB, do not include the Kc expression for the solids or liquids, okay? We don't include the Kc expression for solids or liquids because they have a constant concentration, or their concentration is constant. So there's no need for us to express it on the Kc expression. I hope you guys still remember all of this and we know how to do it. The next thing is to perform calculation based on Kc values. Now, it's very important. This one you must go back and practice on how we do the Kc calculations. The next one is to explain the significance of high or low Kc values. I've already explained to you that if you have a Kc that is greater than 1, that means that you have more products than the reactants. If you have a Kc that is less than 1, that means you have more reactants than the products. So you want to be here as a business owner. You want to have a Kc value that is greater than 1 because you'll be making more products. And if you make more products, that means you'll make more profit with little money to buy your reactants. All right. I hope you guys are still with me, and this is going to assist you. The next thing that I want us to look at or to remind you of is the graphs, okay, of temperature, concentration, and pressure. This one is very much important. Sometimes in this question, the examiner can give you a graph. Now, there are two types of graphs that the examiner can give you. They can give you a reaction rate versus time graph, or a concentration or mole versus time graph, or a temperature versus time graph, or a pressure versus time graph. Or they can have all of these in one graph. So you just need to know what each what the graph actually speaks to you and what is it saying to you. Now, as you can see here, if you are given a reaction rate versus time graph, what you need to remember is that you'll always be given two graphs, okay, in one graph. So if you have two graphs in one graph, normally the dotted lines will represent the reversible reaction, while the bold line will represent the forward reaction. As you can see, even if they don't put dotted lines or they don't put bold lines, or even if both of them were bold, what you must remember is that the concentration of the product will always start at 0, because we know that at the beginning of the reaction, the reactants were not, the products were not yet formed. That's why their concentration will be 0, and their reaction rate will also start at 0. But the reaction rate of the product will always start at a higher note, because we know that the concentration of the reactant is normally in the beginning of the reaction is higher, or it's there. And then as the reaction starts, as you can see, the concentration of the reactant starts to decrease. And if the concentration of the reactant decreases, that means the rate of the forward reaction starts to do what? To decrease, and the rate of the reverse reaction will start to do what? To increase, until both of them, as you see, a straight line, constant line over there. This will indicate that the graph has reached what? Equilibrium. All right. Very much important to remember. And then the next one I want you to take note is that if you are given a concentration versus time graph, you will be given the graph for each concentration of the substance. For example, if here you have A, B, and C, all right? That means if I were to write my equation, I have A reacting with B to give me, must be a reversible reaction to give me C. What is it that I'm seeing? I'm seeing that concentration of A was high at the beginning, concentration of B was high at the beginning because they were reactants. The concentration of C was 0 at the beginning because the product were not yet formed. But as the reaction starts, the concentration of A and B, they start to decrease. And that's why the reaction rate of the forward reaction starts to decrease, and the concentration of C starts to increase as the concentration of the reactants are used up, and the concentration of the product increases until equilibrium is established. Now, it's very important to know how to interpret these graphs. Another thing that I quickly want to remind you, adding a catalyst has no effect, okay, on the equilibrium. Because as you add the catalyst, both the rate of the forward and the reverse reaction will be affected the same way, and then they will reach equilibrium again. So when you add a catalyst, just know that you are increasing the rate of both the forward and the reverse reaction. So it does not have any effect when it comes to chemical equilibrium. That's one thing to remember. Guys, let's quickly look at an activity to help you remember or see how these types of questions in terms of the graphs under chemical equilibrium the examiner might ask. 0.25 moles of A and 0.15 moles of B are introduced into 1 decimeter cubed vessel. A and B react and reach equilibrium. which can be represented by the following equation. There is our equation. A plus B gives us AB. That is a reversible reaction. Take note of something here. Change in enthalpy is less than 0. What does that mean? The forward reaction is exothermic. Very much important to take note of. Here on my graph, I have the concentration of the number of moles per time. I have the A and B, the concentration. We're at a specific point at the beginning of the reaction. And as you can see, the concentration of A and B, since the products were 0 at the beginning of the reaction because the products were not yet formed. But as the reaction starts, concentration of A and B, they start to decrease because the reactants are being used up, and the concentration of AB starts to increase because the products are being formed until equilibrium is what is established. As you can see, equilibrium is established as the concentration of the substances remains what? Constant. Then after some time over there, we can see a sharp rise in the concentration of what? Of B. Why is there a sharp rise? That means that there was a disturbance in equilibrium. What was the disturbance? Increasing the concentration of B. That means more B was added into the system. Then what will Le Chatelier's principle do? It will try to decrease the concentration of B, and then when the concentration of B decreases, even the concentration of A will do what? Will decrease, because the concentration of the reactants has to be used up in order for products to be formed, and the concentration of A and B will increase because the reverse reaction is what? The forward reaction is favored until another new equilibrium is established. And as you can see, there are more changes as you go there. Now let's see if we can answer the question. It says, what are the concentrations of moles of AB and AB at T is equals to 20 seconds? At T is 20 seconds, we can see that the concentration of A over here, the concentration of A, we can see that is 0.15. So the concentration of moles of A, so our A here is 0.15 mole. Now guys, it's very important to read the graph with understanding. Then we look at B. Which one is B? B is over here. What is the concentration of our B? As you can see, the concentration of moles of B will be 0.05 moles. Okay, and then for C, we can see is over there. We get what? C is 0.10 mole. Okay, that is how we go to the answer. Number 2 says, how can we be sure that the system has reached equilibrium at 20 seconds? At 20 seconds, what makes us sure that the system has reached equilibrium is because the concentration of moles of A, B, and AB are constant. Okay, so because their concentration are constant, then this indicates to me that these ones have reached what? Equilibrium. Guys, I hope we are together and you can see how we are arriving at our answers. Number 3 says, give an explanation for the change that occurs at T is equals to 25 seconds. Our 25 seconds is somewhere there. What is the change? The concentration of moles of what? Of B has done what? Has increased. There is an increase in the concentration of B what? Moles. Okay, and then which means that B has been added to the system. Guys, I hope we are still together, and that is the change that occurs at T is equals to 25 seconds. And then let's look at number 4 rather. It says, explain the change in concentration of A and B between T is equals to 25 seconds and T is equals to 35 seconds. A and B, T is equals to 25 seconds and T is equals to 35 seconds. What is happening here? That means here we are using Le Chatelier's principle. What is happening? With the addition of B, right, the concentration of B increases over here, as we said, at 25 seconds, and the forward reaction is favored. Why is the forward reaction favored? Because we must use up the B in order for the concentration of B to do what? To decrease. According to Le Chatelier's principle, so that some of the B reacts with A to form more of the AB, hence A and B decreases and AB will do what? Will increase. So what is it that we are looking for? We are looking for you to say that B will do what? Will increase in 25 seconds. Then the Chatalia's principle will decrease the concentration of B by favoring the forward reaction, because in the forward reaction, A and B is being used up to form what? AB. All right. I hope we are still together, guys. And that is how we were to deal with such a question. Guys, you need to practice and practice more of these types of questions. And that is how we are going to get better, right? Now, let's quickly look at question 7, which is normally acids and bases in most previous question papers. What is it that you must remember here? You must remember how to define an acid and base according to two scientists, Arrhenius and Lowry-Rosted theories. Please go back and look at those definitions. You need to also be able to define an ampholyte. Remember, an ampholyte is the substance that can act either as a base or as an acid. You also need to know how to define hydrolysis. Remember, this is the reaction of salt with water. You must also know how to define the equivalent point. Remember, the equivalent point, it is the point where an acid or a base has completely reacted with either a base or an acid. Now remember, the end point is defined as when the indicator starts to do what? To change color. That is when you know that the end point is reached. I hope you remember all of these definitions. Remember, guys, we also need to be able to distinguish between strong acids and bases, weak acids and weak bases. We also need to be able to name them, okay? Refer to your exam guideline when it comes to this one. Remember, your strong acids, that's where you have your sulfuric acid is an example of a strong acid, which is H2SO4. We have our nitric acid, which is HNO3. We have our hydrochloric acid, which is HCl. So those are some of the examples of your strong acids. Remember, your strong bases also, you just look at your group 1. Most of your group 1 elements that have reacted with OH are examples of your strong acids. That will be your LiOH, which is lithium hydroxide. That will be your potassium hydroxide. That will be your sodium hydroxide. So all of these ones, because your potassium, your sodium, as well as your lithium, they are found in group 1. That's why I'm saying it's easy to remember those strong acids, and then many other more, right? So just to give you a few, your weak acids, remember you have your oxalic acid as your weak acid, as well as your ethanoic acid is an example of a weak acid. Your weak bases, you have a calcium carbonate is an example of your weak acid. Your NH3 is also an example of some of the weak acids. So make sure that you know which ones are your weak and your strong acids, okay? And be able to give the examples. Distinguish between concentrated and diluted. Now, this is very much important to remember. Remember, when the acid is concentrated, it does not mean that it is a strong acid. You can still have a concentrated weak acid. So remember that the word concentrated just means that you have a large amount of the number of moles of either an acid or a base to a volume of what? Of water. And also, when we are talking about dilute acids or dilute bases, remember that it does not mean that dilute acids and dilute bases are only weak bases or weak acids. They can also be strong, but they can be diluted, okay? Remember that diluted just means that we have small amounts of number of moles of acids or as bases to the volume of what? Of water. Remember, guys, we need to also be able to write down equations of aqueous solutions of acids and bases. We also should be able to identify the conjugate acid-base pairs for a given compound, all right? Very much important. We also need to be able to write down neutralization reactions. These ones are given in our exam guideline. Please go look at them, and then determine the appropriate pH scale equals to smaller than larger than 7 of salt in salt hydrolysis. Remember that if you have a pH that is equals to 7 or close to 7, we know that kind of a solution is a neutral solution. When it is smaller than 7, we know that is an acidic solution. When it is larger than 7, that is a very basic solution. You also need to be able to motivate the choice of the indicator. Guys, this one is very much important. Remember, there are 3 types of indicators that you must know. Bromothiamyl blue, okay, it is the bromothiamyl blue. Remember the bromothiamyl blue, we use it when we are dealing with neutral reactions. And how do you identify that the reaction will be neutral? Is if you are reacting a strong acid with a strong base. You see why it's important for you to know which ones are your strong acids and which ones are your strong bases. So if you react a strong acid with a strong base, then your solution will be neutral. Your neutral means that you have a pH that is equals to 7 or somewhere close to 7. And then if you put that indicator in an acid, the color of the acid color, it will be yellow. And then if you put it in a base, the color will be what? Will be blue. So it's very much important to know all of this because they can ask you about the color changes. So it's very much important to remember that. Another type of indicator that you must know is the phenolphthalein. Okay, this one, you only use it when you have a basic solution. Your solution must be very basic when you use this one. Remember, what is a basic solution? A solution that is greater than 7, okay? Greater than 7, okay? Way greater than 7, that is solution will be more basic. Remember, it will be basic. Why will it give you a basic solution? If you have reacted a strong base with a weak acid, then the solution will be basic. And then what color change are you going to see in the acid? It will be colorless. Okay, it will be colorless. And then in a base, okay, in a base, it will be dark pink. Okay, dark pink is very important to know these colors. Then lastly, the kind of indicator that you must know is methyl orange. Okay, methyl orange. This one is easy to remember because when you think about oranges are, sour in taste, and sour taste is some of the properties of acids. So you know that you will always talk to an acidic solution. So this solution will be acidic. How do you know that the solution is acidic? It is acidic if you have reacted a strong acid with a weak base. Okay, strong acid, weak base will give you a more acidic solution. How do you see that this is an acidic solution? If you do your calculation, your pH will be less than 7. Okay, way less than 7. And if you look at the color change in an acid, it will be red. Okay, we know that we associate normally acids with the red colors, and then in a base, it will be yellow, right? So very much important to know which specific indicator to use where. So this one, I hope it's going to assist you and help you remember. Also, you must remember, we are still doing stoichiometry calculations. Remember, that's what I said, based on titrations of strong acid with strong bases, a strong acid with a weak base, a weak acid with a strong base. Calculations may include percentage purity. Remember, we did some calculations of percentage purity in grade 11. Please make sure you go back and look at those calculations. You also should be able to know how to calculate the pH values of strong acids and strong bases using the formula for pH. This is the formula for pH. pH is equals to minus, please take note of that, minus log the concentration of hydronium ions. Please, these arrows are very important. Okay, I mean these brackets, they are very important. They need to be the 4-corner brackets. All right, very much important to remember that. Now, under acids and bases, what are the stoichiometry steps that you need to take as you solve problems, or what are the tips that I want to give you? Make sure that you write the balanced chemical equation for the reaction. This is very important. You copy the formula from the data sheet without attempting to manipulate it first. So you copy it as it appears on the data sheet. Don't manipulate it first. You convert the given data into either mass, volume, or concentration of the reactants or product into moles. Remember, that's what I said. If you are given either the mass, the volume, the concentration of either reactants or products, how do you move from one known to the unknown, you always convert to number of moles. And once you get to number of moles, you then use the mole ratio to move from the number of moles of the known to the number of moles of the unknown. Where do we get the mole ratio? From the balanced equation to determine the number of moles of the unknown substance. Once we get the number of moles of the unknown substance, we can then calculate the mass of the unknown, the volume of the unknown, or even the concentration of the unknown. Guys, this is the data sheet, okay? This is taken straight from the data sheet. You don't have to memorize the calculations, okay? This is not only working in acids and bases only. Remember, we are also using it under chemical equilibrium. We are also calculating stoichiometry under rates of reactions. Remember, this formula there is for calculating the number of moles. N is the number of moles, mass in grams. M is the molar mass. You get that from the periodic table. C is equals to N over V. C is the concentration in mole per decimeter cubed. N is still the number of moles. This is the volume of the solution, because when we speak concentration, we talk about the number of moles per volume of water. Okay, so this volume is the volume of the solution. And then this is another way in which the formula can be expressed for concentration, that is C is equals to the mass, okay, in grams, the molar mass multiplied by the volume. And then over here, it's very important to know that the number of moles is equals to that capital letter N is the number of particles or the number of atoms or the number of anything that you are required to calculate. And then that Na, we know that is our Avogadro's number, which is given as a constant, and we get it from the data sheet. Guys, remember, when you see the word titration, end point, equivalent point, the moment they tell you about titration, this is the formula that you go to when you calculate either the concentration of the acid or the concentration of the base, or you can be asked to calculate the volume of the acid or the volume of the base. Remember, this N is the number of moles that you get it from the balanced equation. This is the formula for calculating the pH. You also need to know how to use it. And this formula over here, you need to know what is the difference between that V and this V, okay? This V is the molar gas volume, which is constant, which is 22.4 decimeter cubed, okay? Very much important. This is at STP. It's very important to know which formula to use at STP. This over here is the formula for the equilibrium constant of water. We normally use it under acids and bases. Also, remember that the Kw is equals to the concentration of the hydronium ion multiplied by the concentration of the OH minus is equals to the Kw constant is 1 times 10 to the power negative 14, which is the pH scale at the temperature of 298 Kelvin or at 25 degrees Celsius. It's very important to know that we only use this formula under a standard temperature, and that temperature is 298 Kelvin or the 25 degrees Celsius. So it's very important to know when and when not to use it. All right, guys. We are quickly going to jump into one of the activities that, I took from previous question papers. Let's try to do this one together, and let's see if we can get into the understanding of the chapter. Right, we have anhydrous oxalic acid is an example of an acid that can donate 2 protons, and that ionizes in 2 steps as represented by the equation below. Here is reaction 1. And that is reaction 2. Then 3.1 says to us, write down one word for the underlined phrase in the above sentence. An acid that can donate 2 protons. Remember, there are different types of acids. We have monoprotic acid. Mono means that that particular acid can only donate 1 hydrogen. We have diprotic acid, which means that that particular acid can donate 2 hydrogens. And then we have a polyprotic acid. Those ones can donate more than 2 hydrogens. All right, so this one would be a diprotic acid. Okay, why is this one a diprotic? Because it can donate 2 protons. All right, which is that H plus. Then 3.1.2 says the formula of each of the 2 bases in reaction 1. Now in reaction 2, if we look at the reaction 2 very closely, we want to write down the formula of the two bases that we see there. In order for us to do that, we first need to identify which one is an acid and which one is the conjugate. Very important. As I can see here, I have HCO2 minus plus H2O. I have H3 plus. That means that H2O is a base in reaction 2 and its conjugate acid is H3O plus. So H3O plus is acid 2. So this one is base 1. So that means that HCO2 minus, this means that this one is an acid 1. Okay. And then an acid 1, once it has donated, it forms a what? A base 2. So which ones are the two bases here? It is H2O and this one over here. So the correct answer will be H2O and COO2 minus. Okay, those two are the bases. So that is how I was able to get to my answer. First, you first identify which one is the acid, which one is the base, which one forms the conjugate, which one forms the conjugate acid, which one forms the conjugate base. All right. 3.1.3 says the formula of the substance that acts as an ampholyte in reaction 1 and 2. Give a reason for your answer. Remember, what is an ampholyte? This is the substance that can act as either an acid or a base. Okay, so in reaction 1, it must either act as an acid or a base. In reaction 2, it must also either act as an acid or a base. So let's look it closely. The correct answer here, if I see it correctly, it would be HCOO2 minus. HCOO2 minus in reaction 1. It is a what? It is a base in reaction 1. In reaction 2, it comes back again here as a what? As an acid, because it is the one that has donated the hydrogen over there. So over here, it becomes a what? An acid. So which one is the ampholyte? The ampholyte is H into COO close brackets 2 minus. This is an ampholyte. Why? It acts as a base in reaction 1. And it acts as an acid rather in reaction 2. And that is how I arrived at my answer. Let's quickly look at 3.2. Give a reason why oxalic acid is a weak acid. Now remember, guys, we said you must know what is a weak acid, examples of weak acids, give a definition why you are calling it a weak acid. Remember, it's a weak acid because it ionizes incompletely in aqueous solution. So if you know the definition, all the time when they say give a reason why this is like this in physical sciences, we are always looking for the definition. 3.3 says a standard solution of COO2 of the concentration of 0.20 mole per decimeter cubed is prepared by dissolving a certain amount of COOH2 in water in a 250 centimeter cubed volumetary flask. Calculate the mass of COOH2 needed to prepare the standard solution. Very important to collect your data. Sit down, write what is it that you are given. You are given the concentration of COOH bracket 2. You are also given the volume. So remember the volume, if you are given in centimeter cubed, what do you need to do? You convert it to decimeter cubed by dividing by 1,000. So now we want to calculate the mass of that needed to prepare a standard solution. Remember when I said if you are given concentration, what do you need to do? Convert to number of moles, because you are trying to move from the known to the unknown. So this is what I've done. There are two options. You can just go straight to the formula. C is equals to M over molar mass multiplied by the volume. The concentration we were given there it's 0.2, and then we are looking for the mass. The molar mass, I go straight to the periodic table. I check what is the mass number for carbon, what is the mass number of oxygen. I plus that by 2, that will be 32. And then what is the mass number of hydrogen is 1. And then I multiply everything by what? By 2. And then I will get my molar mass as what? As 90, if I've done it correctly. And then remember the 250 centimeter cubed, you convert it to decimeter cubed, you divide it by 1,000. If you divide it by 1,000, you'll get 0.25. You put that, and then when you punch into the calculator, you should get that 4.5 grams. All right. Another option is to go the longer route. You first calculate the number of moles, right? And then after getting the number of moles, you use the number of moles in that formula to end up finding the mass, okay? So there are two options that you could have done it, but the main idea is to always move from the known to the unknown. And the safer way to do it is just to convert to number of moles, all right? Guys, thank you so much. We are done with acids and bases. We are quickly going to jump into the galvanic cell. What is it that you remember here? Remember, the galvanic cell is normally question 8 of your previous question papers. What is it that you must remember here? You must remember how to define the galvanic cell. Remember, this is the cell that converts chemical energy into electrical energy. You must remember how to define the electrolyte, which is the solution that conducts electricity through the movement of ions. Remember, an electrode is the solid that also conducts electricity. You must also remember how to define oxidation and reduction in terms of electron transfer. Remember, oxidation, we use oil. Oxidation is the loss of electrons, and reduction, which is Rg, reduction is the gaining of what? Of electrons. You also need to be able to define oxidation and reduction in terms of oxidation number. Remember, oxidation is an increase in oxidation number, while reduction is a decrease in oxidation number. And we see that by looking at the oxidation numbers, indicating that the oxidation number has been reduced. The next thing is to remember how to define the oxidizing agent and the reducing agent. Remember, the oxidizing agent is the substance that undergoes reduction and it is reduced. While over here, the reducing agent is the substance that undergoes oxidation and it is oxidized. I hope you remember all of that. Remember, you also should be able to define an anode and a cathode in terms of oxidation and reduction. Remember, an anode, it is the electrode where oxidation occurs, while the cathode, it is the electrode where reduction occurs. Okay, sorry, let's quickly go back there. Remember, in the galvanic cell, my anode is negative and my cathode is what? Is positive. That is very important to remember. Remember, in the galvanic cell here, we are dealing with a spontaneous reaction. We are dealing with an exothermic reaction. We know that the change in enthalpy, not the change in enthalpy, I wanted to say the EMF, excuse me about that. I wanted to say that the EMF is always positive when you calculate your EMF. All right. What is it that you must remember about the galvanic cell? I also wanted to remind you of the structure over here. Remember, you always have two electrolytes. You have your salt bridge, which connects the two electrodes to complete the circuit. You have a voltmeter over there. You have the electrode. You have the electrolyte. Very important to remember that. Now, you also need to talk about the movement of ions when you study. Check how the ions are moving. Remember, the ions are always moving across the salt bridge, and then we refer to that as the internal circuit. You need to know how to state the direction of the electrons. Remember, the electrons are always flowing from the anode to the cathode, whether you are dealing with the galvanic cell or the electrolytic cell. The next thing you must remember, how to write down the half reactions. So I'm going to remind you over here. Remember, your oxidation half reaction, the oxidation number must always increase. So from Cu to Cu2 plus the 2 electrons. What do you look at? From 0 to positive 2, the oxidation number has done what? Has increased. And then if I write the reduction, half reaction, remember that means that the oxidation numbers must do what? Must decrease. That will be Cu2 plus the 2 electrons. Arrow gives you what? The Cu. So from 2 to 0, the oxidation number has done what? Has decreased. Guys, remember to state or to know how the functions of your salt bridge. We know it completes the circuit. It allows the movement of ions from one electrolyte to the other. You also need to be able to write the overall cell reaction by combining the two half reactions. Okay, remember, if you are given over here copper and Zn, remember how to write the net overall reaction. You will always have Cu2 plus Zn gives you Cu plus Zn2 plus. Now it's very important first to identify which one between copper and Zn undergoes what? Oxidation, and which one undergoes what? Reduction. So this was just an example to show you how to write the net overall reaction or the net ionic equation. The next one, how to use the cell notation or diagrams to represent the galvanic cell. Remember, in the galvanic cell, the cell notation, how to remember it? It's saying A, B, and C. Why A, B, and C? On the left-hand side, I know that I have my anode, and then my B will represent my salt bridge, and then my C is my what? Is my cathode. Okay, very important to remember that the cell notation is not the same as the net overall reaction. Then remember, when you write your cell notation in the anode, for example, if we were to use this example, the anode, we start with the electrode. So the electrode will be Zn there because it's a solid, and then it forms Zn2 plus, which is a solution separated by the salt bridge. Then we want the solution, which is the electrolyte, then phase boundary with what? With the solid. Okay, so the reason why we put the phase boundary, remember, we are separating the phases. We know that Zn is a solid here and Zn2 plus is an aqua. Okay, so I'm not sure between Zn and copper 2 plus at this moment which one undergoes oxidation and which one undergoes reduction. This is just an example that I'm giving you. So for you to be sure, what you need to do, you use the table of standard reduction potential, which will be given to you during your examination. There are two tables that they are going to give you. It's either they will give you both of them, which is table 4A and table 4B. So it's very much advisable that you remember which table you are using at your own school and stick to it and know how to use it. Okay, very much important. If you know how to use table 4A, you can use table 4A for everything. If you know how to use table 4B, you can use table 4B for everything. And remember, you also use this standard of reduction potential to calculate the EMF of the galvanic cell. All right, very important. We'll quickly show you how the table 4B looks like. This was just a screenshot from one of the tables that I got, and then this is what I want to show you. Remember that table 4B, there it is. It does not start from Ni. Remember, it starts with Li over there. Okay, starts with Li plus 1 electron. Then that reversible reaction gives you Li. Now it's very important to know what is happening on the right hand side and what is happening on the left hand side. Remember, as you go up on table 4B, the strength of the reducing agent is increasing. So if the strength of the reducing agent is increasing, that means as you go up the table, the substances on the right hand side, which substances? These substances are undergoing what? Oxidation. And as you go down, the strength of the oxidizing agent is doing what? Is increasing. And we know that the oxidizing agent undergoes what? Reduction. And if it undergoes reduction, what undergoes reduction? Everyone that is over here is what undergoes what? Reduction. And we refer them to as the reoxidizing agents. And as you go up on table 4B, what do we know? You have stronger reducing agents. When you go down, the weaker the reducing agents. Okay, so the most positive reduction potential means that you have the weakest reducing agent. Also on the left hand side, as you go down, the weaker the oxidizing agent at the top, and then as you go down there, you have the strongest oxidizing agents. And remember how to use it very, very well. Remember, over there we were looking at copper. There is our copper, very important. This is the copper that we are always working with. So that is the copper. If we were comparing copper and PB over here, and you wanted to know which one undergoes oxidation and which one undergoes reduction, looking at table 4B, we know that PB is the one that is going to undergo what? oxidation, because as you go up on table 4b, the stronger the strength of the reducing agents, and the reducing agents are found on the right hand side, as I said over there. So Pb is a stronger reducing agent than copper, therefore Pb will undergo oxidation. How will you write the half reaction? You say Pb arrow Pb2 plus the 2 electrons. So you will choose the arrow that goes in that direction on the left hand side, because that shows a increase in oxidation number from 0 to positive 2. And then how would you write the reduction reaction there? That will be copper 2 plus the 2 electrons gives you what? Copper. All right, that's when you know that that is the arrow that you are going to take, because that is the one that shows that the oxidation number has done what? Has decreased from positive 2 to 0. That shows that if the oxidation number has decreased, that means the Cu2 plus has been reduced, and it undergoes what? Oxidation. It undergoes reduction, okay, because it is reduced. It is an oxidizing agent. All right, very much important. I hope that all of this is going to help you remember how to use table 4b to help you. Now remember also with the calculations, if you had to calculate the EMF here, very much important to take note of these values between Pb and copper. All right, how do you do that? You go over here, go to your formula sheet. This will be given to you on the formula sheet. You calculate E cell, that is the EMF of the galvanic cell. Then you use the formula E cathode minus E anode. It's very important that you copy the formula with everything on the formula sheet. Now, if you forgot what is in the cathode, we remember that in the cathode, that's where reduction takes place. And in reduction, that's where we find our oxidizing agent. Again, in the anode, that is where oxidation occurs, and that is where we find our reducing agent. All right, I hope this is going to assist you. What you do, you just go back there, you take the values as they are. Then you go back, let's quickly go back. Which one undergoes reduction is positive 0.34. You come back here, sorry guys, let's go back. You come over here, you put positive 0.34, then you minus with what? You minus with our Pb, which is negative 0.31. So you come here, you put negative 0.31, and then you punch into the calculator, you get the correct answer, and your SI units will be what? In volts. I hope you still remember, guys, all of this, and you will be ready to hit the ground running. Right, now let's look at the galvanic cell. Remember, we said that there are 3 standard conditions at which the galvanic cell operates under. Remember, the 3 standard condition is temperature at 25 degrees Celsius. So that is temperature at 25 degrees Celsius or 298 kelvins. Remember, you also have pressure. Remember, when we speak about the pressure, we speak about the pressure of the gases, and this is a pressure at 101.3 kilopascals. And then lastly, we have concentration, and our concentration, remember, is at 1 mole per decimeter cubed. Okay, remember, they can also give you the standard hydrogen electrode. You need to be able to explain the role and the reference of the standard hydrogen electrode. And remember that the V cell always decreases as the concentration of the product ions increases, and the concentration of the reactant ions decreases until the V cell becomes 0. Then we say that the cell is flat. All right, that is all on the galvanic cell. Then we quickly jump on to question 9, which is normally the electrolytic cell. What is it that you must remember when you're dealing with this one? Remember, you still need to be able to define your redox reaction, oxidation, reduction, as well as oxidizing agents, reducing agents in terms of oxidation numbers, and also in terms of electron transfer. Now, you need to be able to differentiate between the electrolytic cell, the electrolysis, the electrode, as well as the electrolyte. You should also be able to explain the movement of ions in the solution, the direction of the electrons flow in the external circuit. Remember, in the electrolytic cell, the electrons are also still moving from the anode to the cathode. You also still need to be able to write the correct half reactions as well as the overall cell reactions, the anode, the cathode. What you must remember though, which is very, very important, is that in the electrolytic cell, our anode is positive, and in the electrolytic cell, our cathode is what? Is negative. Now you also need to remember that this is a non-spontaneous reaction, and it is an endothermic reaction. And remember, that is the structure of how the electrolytic cell looks like. Okay, another thing that I want you to remember under electrolytic cell, there are 4 cells that are examinable that you need to remember as you go through your revision. First is the decomposition of copper chloride. Remember here, copper chloride dissociates to form only 2 ions, which is copper 2+ as well as Cl-. And remember that the Cl- will be attracted to the positive terminal, or it will migrate to the positive terminal, which is our anode, and then the copper 2+ ions will migrate to the negative terminal, which is our cathode. Remember, that is how you will then identify which one undergoes oxidation and which one undergoes reduction. The other process that you need to remember is the electrolysis of concentrated sodium chloride. Remember here we are talking about the concentrated sodium chloride. So you must remember that when Na+ dissociates as well as Cl- dissociates, there's also water involved. So in terms of which one will undergo reduction between Na+ and H2O, remember that H2O is the one that is going to be reduced in the cathode because it is a stronger oxidizing agent than Na+. So those are the things that you need to remember when it comes to the electrolysis of sodium chloride. And then the next one is the electroplating. Remember, when we are electroplating, we are actually coating a cheap metal with an expensive metal. What you must remember is that the object that you are electroplating is always connected in the cathode, and the metal that you are electroplating with is always going to be connected in the anode. So those are the things that you must remember when you are dealing with the electroplating. And then lastly, the cell that you need to remember is refining copper. Over here, what you must remember is the pure copper and the impure copper. What you must remember there is that the impure copper is always connected in the anode, and the pure copper, you find it in the cathode. I think that is the very important thing that you need to remember when you are dealing with these 4 cells. Now let's quickly look at what other things that you must remember when you are dealing with the electrolytic cell. We are still using the standard potential reduction table, which is either table 4A or table 4B. We've already explained it when we were talking about the galvanic cell, so I'm not going to go into more details as to remember that we said the right hand side of the table 4B will indicate that as you go up the table, the strength of the reducing agent is increasing, and as you go down on the left hand side on table 4B, the strength of the oxidizing agent are increasing. So we've already spoken about this when we spoke about the galvanic cell. Now let's quickly look at an activity that is going to guide us through this question 9. It says over here, the simplified diagram below represents the cell used electroplating for ornaments with silver, which is Ag. P and Q rather are 2 terminals of the battery, as you can see over here. So already when you see the word electroplating, what must come into your mind is, where is the object? Now, if you can see over here, your object is connected across P, and you must remember that the object that you are electroplating, we did indicate that you must remember that it's always connected in the cathode. So the metal that we are electroplating with is connected over there in the anode. Now, the next thing is to look at is that we are not sure what we are electroplating with. However, when we look at the solution over there, we are given Ag+, which is sort of a guide to us to tell us that if we have Ag+ in the solution, that means that we are electroplating this ornament with what? With silver. Now let's quickly look at 9.1. It says, state the energy conversions that takes place in this cell. Remember, in the electrolytic cell, we are converting electrical energy to chemical energy. So very much important to note that. 9.2 says to us, which terminal of the battery, P or Q, is negative? Remember, we said that in the electrolytic cell, our anode is positive and our cathode is what? Is negative. And between P and Q, which one will be negative? Our negative electrode is going to be P, because P is the cathode, and we saw that by seeing the object. attached in the cathode. Now let's quickly move on to the next question. It says to us, write down the equation for the half reaction that takes place at the cathode. Remember, because we are electroplating with silver, in the anode we are going to have silver as a solid that will undergo what? Oxidation. So the silver in the anode will undergo oxidation, therefore we'll have Ag plus arrow, and then gives us Ag rather gives us Ag plus 1 electron. Then in the solution, the Ag plus will be reduced in the cathode. So we are going to have Ag plus 1 electron gives us what? Ag. So what is it that we were supposed to write? The half cell reaction that takes place in the cathode. So the correct answer will be Ag plus the 1 electron gives us what? The Ag. So that is how you are going to be asked such questions, and you should expect this to be 2 marks. Remember that when you are writing your half reactions, we don't include double arrows. You always use 1 arrow. 9.4 says to us, calculate the current needed to electroplate the ornament with 3.25 grams of silver in 30 minutes. And this is what is 5 marks. What is it that you are expected to do? The first thing that you are going to do is convert the number of moles, the 3.25 grams into number of moles. How do we do that? We use the formula N is equals to M over molar mass. Then we take the mass that we are given over here, which is the 3.25. We divide that with our molar mass of silver. You get that straight from your periodic table. Then you punch into your calculator. You should get that answer we are having there in moles. Very important. You then go to the formula of N is equals to capital letter N over the Avogadro's number. Then what is it that you are trying to find there? You are trying to calculate the number of particles or the number of atoms, because you are trying to calculate the current at the end of the day. So you are going to then substitute the number of electrons that the number of moles that you have calculated in the previous question, and then you substitute your Avogadro's number. This one you don't have to memorize it. It's straight from your data sheet, okay? And then you make your N the subject of the formula. If you have done it correctly, you should get that as your answer. And then lastly, you go straight to the formula of N is equals to Q over E, where you are going to be calculating the charge. Because the formula for you to calculate the current, you best need to calculate the charge to get there. So hence our question over here is a multi-step question. So from here, you then calculate over there, whatever that you have calculated there, which is your number of particles, you then divide that with the charge of the electron. Again, the charge of the electron is also a given value from your data sheet, which is the 1.6 times 10 to the power negative 19, and then you cross multiply, you will get your charge over there as 2.889 and 2889.6 columns rather. Remember that a charge is measured in what? In columns. And then you go straight to the formula of calculating the current. You just substitute what you have calculated over there, which is the charge, and then you substitute the time there. Remember that your time you were given in minutes. What is it that you need to do? You need to convert the minutes into seconds. Then you take that 30, we multiply it by 60 to get to the final answer as 1.6 amperes. Another way that you could have done it is using option 2. So I'm not going to go through it with you so that you understand how. So you can choose any option that we have done, either option 1 or option 2 that works best for you, as long as we are all going to arrive at the correct answer using the correct scientific concept. Okay, guys, thank you so much for joining in today's lesson. I hope this paper 2 revision is going to assist you as you prepare for your final exam. And good luck. My name is still Dimporampora, and thank you for joining in.